The measurements obtained for the interior dimensions of a rectangular box are 200 centimeters by 200 centimeters by 300 centimeters. If each of the three measurements has an error of at most 1 centimeter, which of the following is closest to the maximum possible difference in cubic centimeters between the actual capacity of the box and the capacity computed using these measurements? So this question here is like this could be a really traumatic question because there's really nothing I like about this question. There are really no hints within our prompt as to how to approach this, and there aren't really any other questions that are similar to this question that I can sort of draw on from the past. And so this is a question I would almost certainly not hesitate to move on from if I thought it just wasn't worth the time and if I couldn't figure out a way to do it. And so the one thing I could come up with that was, the best solution might be this. So here, let's start by drawing our box. Let's say our box looks like this, and so they say it's 200 by 200 by 300. So let's say it looks something like this. And the real best way of doing this might just be to multiply out with the new dimensions. So 201 times 201 times 301, which if you're comfortable with multiplication might take you a while, but is still doable. So maybe that really is just the best way of doing this. But people are unlikely to do it because they tell you to approximate. So they say, which of the following is the closest? So I don't even know about that. But so the best estimation method that I can think of is to think of it sort of something like this. So what we want to do here is see what happens when we expand each of our sides by 1 centimeter. So how can I estimate what 201 times 201 times 301 is? And my current volume is going to be 200 times 200 times 300, which is going to be, so 2 times 2 is 4, times 3 is 12, so 12 million. So then I want to estimate, well, what can this be? And so you can almost think of it this way. So if you think of it in terms of, and so this is going sort of back into the page. So let me copy that a couple of times. So if we are expanding all of our dimensions by 1 centimeter, let's see what happens each time we do this. So first I expand my width here by 1 centimeter. So I add an extra 1 centimeter here. And so if I want to know, if I want to approximate, so what additional volume does this additional centimeter here add to my entire rectangular box? Well, it's going to be the additional height that I added here is 1 centimeter, but it's still going to be by the other dimensions. So 300 and 200. So this will be 60,000. So then let's say, so then when I add my 1 centimeter to this guy over here, well, how much additional volume does that add? So it's going to be the additional centimeter added here, but it's still going to be by the rest of my volume. So it's going to be 1 by 200 times 200, which is 40,000. And this is all in cubic centimeters. And then what's going to happen with the additional centimeter that I add on to here? So how much extra volume does this add? And so this is going to be the same as this guy here because they were equal to each other before. And so it's just going to be 1 times 200 times 300. So this is just going to be another 60,000 cubic centimeters in volume added. So total, I roughly just added 60,000 plus another 40,000 plus another 60,000, which is 160,000. So this is a very sort of, I would call it a novel question. And the best advice is really if you get stuck, or really, I would say more likely, if you can't get it started, just move on. Might not be worth the time.